All right, so this is the definition for a polynomial function of x, polynomial function of x of degree n. All right, so that's a general definition for a polynomial function, and it just means that if a of n does not equal 0, then whatever x we have after the a of n and the power that x is 2 determines the degree of the polynomial function, right? So I could just have f of x equals, I could just have this, x to the 4th, and that by this definition, because the only thing that can't be 0 is a n, all of these could all be 0. And so this is a polynomial function of x of degree 4. So this is a 4th degree polynomial function, right? And of course you can have other terms after it. 3x cubed minus 2x squared. I mean, we skip the x term and we just go straight to 2, right? That's fine too. It's just that whatever the biggest power of x is in that function, that determines the degree of the polynomial function, okay? Now, what this chapter, though, is all about is not just polynomial functions in general, but it's specifically a look at quadratic functions. In quadratic functions, that's a function where the highest power of x is 2, it is 2. So we've got an x squared term basically. So this right here would be a quadratic function. All right, so I'll write a formal definition of that on the board for you. So let A, B, C be reals. I'm going to draw that line. I don't think you guys didn't see that, but that's you'll find that in other math books where you kind of do the R with a double line on the left there defining that symbol means reals. Let A, B, C be reals with A not equal to 0, then f of x equals ax squared plus bx plus c is called a quadratic function. Now it's a quadratic function, but it's also a polynomial function, right? And it's a polynomial function of x of what degree? 2. It's a 2nd degree polynomial function, right? Because the highest power on any of the x terms is 2, all right? And remember, those could be in any order. It's just we're looking at whichever x term has the highest power. That defines the degree of that polynomial function. So we have a special name for a polynomial function where the highest power is 2, and we call that a quadratic function, okay? Now we've dealt with the quadratic function before, because the only thing, again, that can't be 0 is this first term here, and so they're just basically saying it's got to have an x squared term in it, right? But all the other terms could be missing, and we've dealt with the function we've dealt with the graph, of a quadratic function before in its simplest form, right? We've dealt with f of x equals x squared. So that's as simple as you could get with a quadratic function. It's got to at least have an x squared term in it, none of the other terms have to be there, right? And so this looks like, you guys remember, because we talked about this when we were reviewing the quiz, this looks like this, right? That's the graph of x squared. Does anybody know what that shape is called?
Parabola.
A parabola, right? So 2. And I've actually been doing a terrible job of writing down names. I just realized we've had participation from Stephen and Adeline and Hayden and even Claire said something. I noticed that. Good job, Claire. So Claire. probably someone else, but I don't remember. So you guys will have to remind me by participating again, all right? So that's a parabola, that's correct. That's that basic shape. And it's a U-shaped curve, right? We see on, they noted in here that there's a lot of different naturally occurring things that you might study that involve parabolas. It says especially in real life applications that involve reflective properties such as satellite dishes or flashlight reflectors. So when you begin to study the science behind that, you will encounter parabolas. But all parabolas are symmetric with respect to a line called the axis of symmetry. So there will always be somewhere an axis of symmetry, a line that you can draw down the center of your parabola, right? And you can flip it around that line and it will look the same. And so for this particular, for the basic f of x equals x squared, where is that axis of symmetry? It's just the y-axis, right? It's just this line that we call the y-axis on our graph. So when you start dealing with quadratic functions, you may see that parabola move all around and flip upside down, you know, but there will always somewhere be an axis of symmetry that you'll be able to identify. And the point where the axis intersects the parabola is called the vertex. So that's this point down here, right? That is the vertex. When we're talking about parabolas. So any questions about the basic graph for a quadratic function? Parabolas, axis of symmetry, vertex, any of that stuff? So we just write down y-axis is axis of symmetry. Just make sure you're familiar with that term. With all of these terms here, just if you see instructions on a test that include those terms, I want you to know what they mean. All right, so let's do something we've actually done before, but this will be good to refresh ourselves in that because you're going to see it on the test, the chapter 1 test, right? So it says sketch the graph of the function and describe how the graph is related to the graph of f of x equals x squared. So they give us two graphs, or two functions, sorry, g of x equals x squared negative x squared minus negative x squared plus 1, right? And so let's sketch that one first. What is the graph of that guy going to be? What are we looking at here when we think back to our chapter on transformations, transforming these graphs? How is the original x squared function going to compare to this new function? What's going to happen to the original x squared function? Yeah.
It's going to move up 1, right?
It's going to move up 1, so he got that from this, right? And what about that negative side of the front? What's that going to do to it? Yes?
Will it make it like go the opposite way, so it'll go down instead?
It will flip over. So it's important that we know with the negative in front there whether it's going to flip it across the y-axis, the x-axis, or flip it across the y-axis. And so you're right. In this case here, because the negative's in front, then it would flip it across the x-axis there. So our new function is going to look like it moves over 1, right, by this plus 1 here. Oh, wait a minute, sorry, it moves up 1. Is that what you said, Hayden? Up 1? Mm-hmm. Yeah, it moves up 1. So our new vertex is up here. And like Steven said, it's going to open downward now instead of upward. And you can see as I'm drawing that, there's some key things I'm going to be looking for if I asked you to do that, right? And that is that you understood it went up 1, so your graph should have labeled that, right? And it's it's y on it's 1 on the y-axis now. And that it's opening downward. Also, I'm looking for that. But you can also just kind of do a quick check here along the x-axis and see that if I plug in 1 right here as my x value, I'm going to get -1 plus 1, so that's going to be a place that it crosses the x-axis, right? So there's some kind of quick, simple numbers you can plug in there just to verify that your graph is accurate. What if it wasn't this? What if it wasn't flipped downward, but if instead it was flipped across the y-axis? How would that be different from this here? Suppose I gave you instructions and I said, I want you to take f of x equals x squared, and I want you to give me the new function. I don't want you to graph it, but I want you to give me the new function if it was flipped across the y-axis. What would it be?
It would have to be within parentheses, right?
That's right. So the negative sign, the new function would have to be -x squared. Right? That would flip it across the y-axis. And then if I told you I wanted to flip it across the y-axis and moved up 1, then you would do the same thing here.
And then what would that look like?
What's that?
And then what would that look like?
So that would look like this, except it would just be up here. Right? Because when you flip it across the y-axis, it looks the same. Now, what if I said though, instead of moving up 1, I want it to move to the left 1.
You have to in parentheses and do +1 to the x squared, so it'd be g of x parentheses x squared plus 1.
But I also want it flipped about the y-axis, so it'd be g of x, just like we have here, negative x.
Plus 1.
But the plus 1 goes into parentheses. Does everybody follow that? So then it won't be like this, but it will instead be, it could be over here, 1, right? Make sense? So just make sure you guys are clear on when you have to use the parentheses and when you don't. That last quiz, I gave you guys credit for showing me the graph when I told you to transform it on the back page there. In fact, I don't even think I counted the back page because there was so much confusion over whether I asked for the graph. Maybe I did. I don't remember. I've graded so many quizzes here lately, I'm getting confused about which class. But that back page, what I was actually looking for was this. I was looking for the function, not a graph of the function. So when I told you to transform it, I wanted you to tell me what the new function looked like. Okay? So you'll definitely see that on the test, that concept. Any questions about that? So this is one they told us to graph. The other one that they asked us to graph was h of x equals x plus 2 squared minus 3. So just glancing at that, what's going to happen to the graph of x squared if it's transformed this way? The x value will change, so which way will it move? You're talking about for the vertex, right?
Yes.
So which way will it move?
It'll move left.
It'll move left, how many units? 2. So she got that from here. Let's just forget your name. Ah, it's Lily. Right? Okay. So she's right, it moves left 2. And then what's that -3 on the outside going to do to it?
Move it down 3.
Moves down 3, right? So left 2 and down 3. So 1, 2, -2, 2. See, like in this case here, you just have to show me where that vertex goes to. So left 2, down 3 is going to open upward or downward? Yeah, we didn't do anything to change which direction it's going to open, right? So it's still going to be opening upward, so it's going to look like that there. Now, you guys have graphing calculators, right? And so if I give you this here and say, draw the graph for that, you can always punch that in your graphing calculator and say, yep, I got it right. But what might be hard to see on your graphing calculator is what this exact point is. And that's why it's going to be so critical that you show me you know what that vertex is, right? I want to make sure that you know where the vertex moved to. And then I'll be looking to make sure it opened upward versus downward and all that stuff. Any questions about that? All right, there's another form of the quadratic function, so we want to that real quick. And this is called the standard form of quadratic function. So standard form and standard form looks like this. It's f of x equals a x minus h squared plus k. Again, a cannot equal 0 because we've got to make sure we have that x squared term in there. And so if we have the quadratic function in standard form like this, there's a couple of things that we can just from glancing at the equation we can figure out. And that is, this is a parabola whose axis is the vertical line x equals h. So the h term here tells us where the axis of symmetry is. So we can just glance at the function and know that. And whose vertex is hk. So we can also see exactly where that point is for the vertex if we've got it in that form. And then finally we can look at the sign of the a, and that will tell us if it opens upward or downward. So when a is greater than 0, which ones are you guys going to guess? Will it open upward or downward? It's going to open upward. If you think about the way our transformations work, right? When the negative sign came in is when it flipped directions. So when a is greater than 0, it opens upward. And the opposite is true when a is less than 0. Opens downward. Plug my little useless gadget back in. I wonder if it was a distance thing, but what's the point if you can't stand 6 feet away, and it worked? All right. So based on that, let's look at a quadratic function and see if we can rearrange it, put it in this form, and then we'll be able to know all this information about the graph of our function. All right. So they give us this function, f of x equals 2x squared plus 8x plus 7. And we need to put it in this form here. So what we're going to do is we're going to kind of split off this constant term all by itself here to start with. And we're going to factor out any number we can factor out here. So we're going to factor out our 2. And so this becomes x squared plus 4x. We'll throw 7 over here by itself. Anybody confused about how I did that? So we're getting there, right? It's already looking more like this, but we need to have the square outside there. Anybody have any idea how we can take this guy here, take this term here, and turn it into something that is a perfect square, right? That's what this is. This x minus h squared, we've got a perfect square there. And remember a trick that you should have learned somewhere previously, maybe algebra 2. I don't know, maybe before that. I had no idea when you learned this concept. What?
Maybe algebra 1.
Maybe algebra 1 that long ago? So completing the square, you think it was that long ago?
I think so.
Yeah, okay. All right, well, good. So you guys should be well versed in it at this point, right? Completing the square. And that's one of those things, if you haven't done it in a while, it's going to be like, wow, this is really fuzzy. I don't remember this. But when we completed the square, you basically take whatever that last term is here, and you divide it by 2, and then you square it, and you add that to the end. All right. So for this one here, if I look at my middle term, which has a 4 on it, when I say my middle term, sorry, the one with the x term, and I take that 4, the coefficient on that, and I divide it by 2, that gives us 2, and then if I square that 2, I get 4, so I'm going to add that in right here. All right? But if I just add in a 4, now I've just changed the value of my function, so what am I going to have to do so that I don't change the value of my function?
Put in a negative.
I got to subtract that 4 out, right? So I got to have something that looks like this. So since I added the 4 in, but then also immediately subtracted it out, I haven't changed the overall value of my function. Did I lose anybody on completing the square? Everybody clear on that? Just to make sure you're clear, it's a little less obvious because there's the number 4 is there, and you get the 4 right here. What would, if I was completing the square for that, what would it be?
9.
It would be x squared plus 6x. I would take half of the 6, which is 3, and I would square that, making it 9. So right, it would be plus 9. Right? And then I'd have to subtract out 9. Alright, so now we still don't look like we're any closer to making this look like this, but we actually are. So now what we have to do is we have to pull this negative 4 out, because this is it's that series of terms that if we were to factor that, it turns into a perfect square, right? So we've got x squared plus 4x plus 4, so this is what we want there, but we can't just lose the negative 4, so what are we going to move outside of our parentheses now to accommodate that negative 4 that's hanging on the end there? Can I just take the negative 4 and pull it out like that? Huh? No. Why not?
Because you have the 2 in front.
Because what by 2 in the front, right? So I actually have to move out negative 8. Because that's 2 times negative 4. Right? So if I do that, I've still got the same function. Did everybody follow that step? So now we can take this guy here, and because it'll factor into a perfect square, it becomes x plus 2 squared. And then we just combine our like terms here, and we've got a minus 1 hanging out on the end there. So do I need to run over any step in that process for anybody? Did I lose anybody anywhere? Because now I've got an equation that matches standard form of a quadratic function, right? And so with that being the case, then I can tell you, looking at this, I can tell you where the axis of symmetry is. Where's the axis of symmetry? X equals, where is it here? X equals what?
H.
H. So what is H in this function? Is it a positive 2 or a negative 2? Claire's like, I don't know about that. I'm like kind of like Claire. I don't know about that. Because see here, in the original function in standard form, it's got a negative on it. So if this is plus, then we've got to say that this is, in order for it to be negative, we'd have to write it as 2x x minus negative 2 squared minus 1. Right? If I wrote it like this, then it should make it obvious that h is actually negative 2. Does that make sense? Not positive 2. So the axis of symmetry is x equals negative 2. Alright? That makes sense to everybody? And then where is the vertex? We've already identified that h is negative 2, so our x coordinate is negative 2. What's our y coordinate?
Okay, so -1.
-1, right? And then we can say, is it going to open upward or downward?
It's gonna open upward because 2 is positive.
Yep, opens upward. Because 2 is greater than 0, right?
Which two?
Sorry, this is next.
Oh.
One in the front. Yeah, A. The A term, right?
Okay.
Because A is positive, yeah. Yeah, they definitely should have done this to where all the numbers were different, so it'd be real clear when you write it down, right? I don't like what they use for the completing the square, nor the fact that they have 2 2's in there. All right, any questions overall about that? And so we could, you could throw up a quick graph of that, right? Our vertex is -2, -1, so we'll go 2, -1, so it's going to be down here, and it opens upwards, so it's going to look like this there. All right. Now, to help you graph it a little bit better, we can also identify the x-intercepts of a quadratic function pretty easily. And the way that we do that is by setting the quadratic function to 0 and solving for x. So, do an example of that. Because if at our x-intercepts, in other words, where this graph intersects the y-axis, where our graph intersects the x-axis, what's the value of y going to be? Huh? 0, right? And so if we solve this equation for when it's equal to 0, then we'll determine where it crosses the x-axis, right? So they give us this equation here. Describe the graph of f of x equals -x squared plus 6x minus 8. And identify x-intercepts. And identify x-intercepts. And so for the first part of this, we would do exactly what we did before. So we can try those steps real quick to give us a little practice, a little more practice with that. We're going to take our, we're going to take -x squared plus 6x, and we're going to group that together, minus 8, right? We're going to pull out the negative sign in the front there and make it -x squared minus 6x minus 8. Then what's our next step?
So do the square.
Complete the square, right? So now we've got -x squared. We take half of -6, which is -3. And then we square that, which is going to be a positive 9, so -3x plus 9. We have to subtract out the 9, so we don't change the overall value of the function, so it looks like that. And then we're going to pull that 9 out, and we've got, the -9 out, so x squared minus 3x plus 9. If we pull out the -9, it's a -9 times the negative sign in front, so we're actually pulling out +9. So this is -8 plus 9. And so we get this x squared minus 3x plus 9 turns into, did I do that right?
It's supposed to be.
It
I don't think it's.
I lost my 6, sorry. I was like, that's not adding up correctly. Thank you. So now this becomes x minus 3 squared plus 1 out here. So now we've got it in standard form. So now we can, if we draw our graph here, we know that based on this negative sign in the front, it's going to open in which direction? It's going to open downward this time. What's that negative sign there? We also know that our vertex is going to be what?
Negative 3, 1.
You did it again, Hayden. This is negative here, then h is just
Oh, it's just
positive 3, right? So that's something that keeps coming up. Make sure does everybody follow that? I'm glad that you're making the mistake because that's an easy mistake to make with this because the standard form equation has a negative sign in it, right? So since this is negative 3, then our h in this equation is for this equation is just 3, right? So it's 3, and then k is positive 1, right? Everybody agree with that? So this is our vertex, 3, 1. So we could come out here, we could say 1, 2, 3, 1. So we know we've got a vertex right here. We're just going to leave that there for now. We know it's going to open downward, so we'll maybe we'll sort of do that little line there to show us that it's going to open downward. Any questions so far? So the next step is find our x-intercepts, and the way that we do that is we take our equation and we set it equal to 0. And so our original equation was negative x squared plus 6x minus 8 equals 0. We need to factor out this negative sign here, x squared minus 6x plus 8 equals 0. And we can actually factor this guy, right? So what's that going to be? We've got x here and x here. Somebody who's really good at that. Somebody tell me what would go here and here.
Be minus 4 and plus 2.
Minus 4 plus 2. Well, if we did minus 4, then we'd have negative 4x plus 2x, which would give us a negative 2x in the middle. And it'd also give us a negative 8 there. So it's negative 4 minus 2. Right? All right. So now if we do that, then we set up each of these terms equal to 0, then we can say that x minus 4 would equal 0 and x minus 2 would equal 0. So x would equal 4 and x would equal 2, right? So those will be our x-intercepts. So x equals 2 here, and x equals 4 here, so our graph is going to look like that. Did I lose anybody in this process? Everybody track it with me. All right, one final thing that we can do is we can find minimum and maximum values. And let's see, what is this one here? Write the standard form of an equation. Oh, then let's do this. Let's do this example real quick. I want to make sure you know how to do this. So they give us a parabola whose vertex is 1, 2, 1, 2, and passes through the point 3, negative 6. All right? And they say, write the standard form of the equation. Write in standard form. So they tell us this is the vertex, and this is just a point on the graph, right? And so standard form would be somebody tell me what's going to go inside this part of it. I'm going to put my A in the front here. So we don't know the value for A yet. What's going to go inside there?
So x
Yes, you got it. You got the h right that time. Perfect. Because then the h is positive in our point. So it would say like this, x minus 1. Everybody clear on that? And then what is k for this one? Positive 2, right? So plus 2. So we're almost there. We just got to figure out what that a is, right? Any idea how we figure that out? Based on the information they gave us? Plug in the point, right? We did the same thing. You did this when you were studying lines, right? When you're finding the slope and the y-intercept, and they would give you the slope, but they wouldn't give you the y-intercept, but they say this point's on the line. We'd figure out the slope. We'd have 2 points, right? We'd figure out the slope from the 2 points, and then we'd take one of the points and plug it in the equation and solve to find b, right? So we're going to do the same kind of thing here. So our equation, if we replace f of x with y, is a x minus 1 squared plus 2. So now we plug in our point, and our point here is -6 for y equals a, positive 3 for x minus 1 squared plus 2. So we're just going to multiply that out. -6 equals, this is just 2 squared, right, which is 4. So we got 4a plus 2. And we move our 2 over, so we got -8 equals 4a. And so a equals -2. And so now we can write the final version of the equation, which is f of x equals -2x minus 1 squared plus 2. All right, any questions about that? All right, so let me just give you a couple of formulas very quickly to find the minimum and maximum value of a function, and then we'll be done for today. All right, so minimum and maximum values. Quadratic function. If we have a quadratic function like this, f of x equals ax squared plus bx plus c, and has vertex with vertex -b over 2a, comma, f of -b over 2a. Now that's kind of bizarre, but where they got this is that if you complete the square for the quadratic function, if you take the function f of x equals ax squared plus bx plus c, and you complete the square on that function, then you can rewrite that function as f of x equals a x plus b over 2a squared plus c minus b squared over 4a. So this is the same thing we did when we were completing the square earlier on an equation that was in standard form when we had the actual numbers in there. But this is just completing the square by leaving all of the variables in there. And so you would come up with that. And so notice if we do that, then our vertex, if our function is in this form, which matches standard form, then our vertex is going to be h is -b over 2a, right? Because remember our original function said ax minus h squared plus k. So the point where our vertex is basically the negative of this. So negative b over 2a, which is exactly what we have here. And if I wanted to know what the y value was for my vertex, then I could just take this x value here and plug it in my equation, right? Because anytime I have any kind of equation, but the quadratic equation as well, if I've got this equation here and I want to see what the y value is for that equation, if x is in a certain place, like if x is 2, I can just plug in a 2 for x here, and whatever I get would be my y value, because this could also be written as y equals that, right? So all this is saying is the vertex is this point that we got by this x coordinate by completing the square, and then the y value would be plugging that x coordinate in. All right? And so this is what it's saying. These are our rules. If a is greater than 0, then f has a minimum at x equals negative b over 2a. So the minimum value is f of negative b over 2a. So if a in our equation is greater than 0, which means our parabola is going to open which way? Up, right? If our a is positive, then the parabola is going to open upward. And so then it should make sense that our function is going to have a minimum value, not a maximum value, because it's opening upward, right? And so the opposite is true. If a is less than 0, then f has a maximum at x equals negative b over 2a. The max value is f of negative b over 2a. So how would I use this information? All it's saying, right, is that this x value here, if a is positive, then the x value here is going to tell us there's a minimum right there. If a is negative, then this x value in this coordinate here is going to tell us that there's a maximum there. If a is positive, it's opening upward, so it makes sense since our graph is keeps going that way. There is no maximum, but there will be a minimum, and if it opens downward, right, it makes sense that that would be a maximum for the function. Okay? And so this is how we can quickly figure that out. So there's an example here that says they give us an equation. And this is it's really simple to use this and plug it in. But they give us an equation, the quadratic function. They tell us that the baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. We don't really care about all that information. What we care about is the function they give us. The path of the baseball is given by this function, f of x equals negative 0.0032 x squared plus x plus 3. They give us a quadratic equation, and they said, what is the maximum height reached by the baseball? All right? And so all we have to do, first of all, because this has a negative sign here, our a is negative, we know it's going to have a maximum, right? Because of this rather than a minimum. So we know that's, because the negative's in the front here, we've got a parabola that looks like this, right? And so we know, based on, so we're looking at this, we know that there will be a maximum when x equals negative b, and our b in this equation is 1, right? So 1 over 2a, and 2a is negative 0.0032. So that's pretty simple, right? We're just plugging those a and b values in. And when we plug that in our calculator, we get 156.25 feet. Because that was our original unit. Now we would expect it to have a positive value because we won't have any negative values in a real life scenario like this. So we know that there's a maximum when, if you think about this as a number line here, right? There's a maximum at this point when from wherever we originally hit the ball, we reach 156.25 feet. But what is our maximum point on the y-axis? And the way we figure that out is we take this x value now and we plug it back in our equation. All right? So we say f at 156.25 equals negative 0.0032 156.25 squared plus 156.25 plus 3. And when we punch all that in our calculator, we get a value of 81.125 feet. So this may look kind of complicated, but actually using it's pretty simple, right? You really just have to remember this piece here, right? That our x coordinate is negative b over 2a. So that'll give you the x coordinate, and you just have to remember it'll either have a maximum or minimum based on the sign of a. Okay? All right, I will assign the homework assignment. I'll put that in Google Classroom. All right, just be one chapter, but that'll give you plenty of time. Should give you plenty of time to study for your test this week too. Which, like I said, that will be given to you to take home. But what would be the smartest thing for you to do is when I give it to you to take home next week, is go ahead and take it right away before you start doing any new work. Right? All right. Any questions? Yes.
So do we have a quiz and a test next week?
So you will still have a quiz. You'll have a quiz over this material, but the test will be take home.
But we'll have homework with the test, right?
What's that?
We'll still have homework too, right?
Yeah, you will. There'll still be, I'm going to assign homework related to this chapter here, so you're going to have to still be doing that while you're studying for the test. Okay? I wish we didn't have to do that, but we just don't have to because we're so limited one day. All right? Y'all have a good day.